If you are watching this right now, chances are you are trying to make a big decision. You have probably heard the terms machine learning engineer and AI engineer thrown around everywhere, and everyone online seems to have a different opinion about which one you should become. Some people say ML is the real AI, others say AI engineering is just hype, and many people end up trying to learn both at the same time and make almost no progress. That's exactly what I want to help you avoid. Because the biggest mistake I see people make is not choosing the wrong role, it's trying to prepare for two completely different jobs at once without realizing how different they actually are. So, in this video, I want to break down what's really happening in the market, what these roles actually look like day to day, and how you can decide which path makes sense for you without wasting months or even years. Let's start with the current reality. Right now, companies are not racing to invent brand new AI models. That work is mostly being done by a handful of large research labs. What most companies actually need is people who can take existing models and turn them into real products that solve real business problems, integrate with real systems, and are safe enough to ship to real users. That's where AI engineers come in. An AI engineer's job is not to reinvent the model, it's to apply it. You might be building an internal tool that lets employees search thousands of company documents instantly, or you might design a system that analyzes customer feedback and surfaces actionable insights automatically, or maybe you are integrating speech to text recommendation systems or summarization into an existing product. Notice what's common across all of these examples. The value does not come from the model itself, it comes from how the model is used. This is why AI engineering is growing so fast. Modern AI models are flexible. They work across industries, healthcare, finance, education, logistics, media. All of them can benefit from AI if it's integrated properly. And because these models already exist, companies don't need you to understand the math behind every layer. They need you to understand how the model behaves, what its limits are, and how to use it reliably. That means the real skills are software engineering skills, designing APIs, managing data, handling failures, thinking about security, monitoring performance, making sure the system actually improves the user experience instead of just looking impressive in a demo. Now let's contrast that with machine learning engineering because this is where a lot of confusion happens. Machine learning engineers are much closer to the research side of things. They are often responsible for training models, not just using them. That means working deeply with the data distributions, feature engineering, evaluation metrics, bias detection, and optimization techniques. They deal with training pipelines, validation strategies, and constant experimentation to improve model performance. This work requires a strong foundation in mathematics, statistics, and data science. And yes, software engineering still matters here, but for a different reason. The code exists to support experimentation and training, not to ship a user facing product as fast as possible. Here's the hard truth that people rarely say out loud. If you're trying to break into machine learning engineering without a strong academic background, you are stepping into extremely competitive territory. You'll often be competing with people who have master's degree or PhDs and years of focused research experience. It's not impossible, but it is a long and demanding path. AI engineering, on the other hand, is fundamentally an extension of software engineering. And software engineering has a proven track record of being learnable outside traditional academic paths. Thousands of people have built successful careers by learning how to code, how to design systems, and how to ship reliable software. AI engineering builds on that same foundation, but adds a powerful new capability integrating intelligent models into application. And this difference shows up clearly in the day-to-day work. An ML engineer might spend their time tuning hyperparameters, analyzing model bias, or improving accuracy on a benchmark dataset. An AI engineer is more likely to be running experiments in production, measuring whether a new AI-powered feature actually helps users and iterating quickly based on feedback. One role is focused on theoretical improvement, the other is focused on practical impact. Now, let me make this concrete with an example. Imagine you build a voice transcription tool. The user records audio, the system converts it into text, and then another AI model cleans it up, removing filler words, fixing grammar, and improving clarity. Under the hood, you are working with browser APIs, backend services, model inference, and data flow between components. This kind of project demonstrates exactly what companies want from AI engineers. You can explain it clearly, you can show how users benefit, and you can talk through the technical decisions without needing to write equations on a whiteboard. That's a huge advantage in interviews. And this brings me to another important point: future proofing. You have probably heard people say that AI is going to replace developers. But here is the reality: As AI becomes more powerful, the need for people who know how to apply it correctly actually increases. Models don't deploy themselves, they don't understand business context. Even in a world with extremely advanced AI, companies will still need engineers who can integrate, configure, and control these systems. The work shifts, but it does not disappear. So, what should you do next? First, stop trying to learn everything at once. Decide which role you are actually aiming for. If you enjoy building applications, working with APIs, thinking about system design, and seeing users benefit from what you build, AI engineering is likely a much better fit. Second, focus on building end to end projects. Not toy notebooks, not isolated demos, real applications that show how AI fits into a larger systems. These projects become your proof of skill, your interview talking point, and your confidence booster. And finally, remember this, progress comes from clarity. Once you stop splitting your attention between two different career paths, learning becomes faster, deeper, and far less frustrating. Choose intentionally, build with purpose, and you'll be much closer to landing the role you actually want.